the last lecture, right? So we'll start from this one. This one is transfer station. So the waste transfer and transport. So we'll see those activities associated with the transfer of waste from the smaller collection vehicle to larger ones, and the subsequent transport of the waste usually over long distance to the disposal site, meaning landfill. So in this case, transport and transport operations become necessary when haul distances to available disposal site or processing centers increase to the point that direct hauling is no longer economically feasible. Like say, for example, if you need to drive 200 miles just with a smaller truck doesn't make sense. That's why the transfer station is very important. Important factors that must be considered in the design of transfer station include type of transfer operation to be used, capacity requirements, equipment and accessory requirements, and environmental requirements, means regulation. We have to follow the regulations. So depending on the methods of used to load the transfer vehicle, transfer station may be classified into three types: direct discharge, storage discharge, and combined direct and storage discharge. The main purpose is to reduce the number of vehicles that must travel to disposal site and thus save money, right? So that's the main idea of the business point of view. So this is the one typical transfer station. So it shows like, say, you see these are the one queuing area. This is a big truck waiting here, and this is the platform that the smaller truck can come and dump into that. So this is direct discharge. What does it mean in this case? The smaller truck coming here. So you see this is the one and directly dumping into the bigger truck. Bigger truck is waiting here. Okay. So in this case, we can call it direct discharge. There is no like say a transfer or anything like that. So once the truck is full, then it goes to somewhere else into the bigger landfill or somewhere that can discharge finally. This one is storage discharge. Like say, you see these guys are coming here, storing here. Then another truck or small truck is pushing the waste to the bigger one here. So that means it's storing here a little bit, then it's dumping to the another truck for transfer. So that's it called the storage discharge. And the third one is basically, I don't have it here, but they combined. So the same facility might have both in the sense of like say they can store and push it, or some part they have both. So waste recycling and reuse, we want to define few terms because these are very important. Reduction in generation, reduction in amount of material, increase in lifetime, eliminate the need. So then the few terms that will define: reuse, no transformation. Whenever we use it as it is without any form of physical chemical transformation, we call reuse. Recycling, use of material as a source raw material, involves physical, maybe chemical transformation. Recovery, process to recover useful material from mixed waste. Energy is an example. Or it could be separation of some of the materials, glasses, cardboards, and everything could be part of it. So the recycled materials include construction waste, tires, aluminum cans, metals, furnishing and clothing, plastics, air waste, glass, animal waste, paper waste, and so on. Mandated reductions in the USA: 25% by 95, 30% was 2000, 35% by 2000. So in this case, when usually the state didn't approve or allow any renewal of permit or expansion of a landfill permit until they meet those requirements. Okay, until they meet those requirements. So state recycling rates, in this case, showing the picture in here, looks like a 0 to 9% is, these are the one, these colors, right? And this is the color 10 to 19, 20 to 29, 30 to 39, looks like these are the one: Washington, Oregon, California, Texas, Arkansas, Missouri, Idaho, Wisconsin, Kentucky, Tennessee, Georgia, Florida, New York City, right? NC, North Carolina, sorry. And here is the Vermont and the Massachusetts. So these are the one looks like met the requirement: 32, 39, 40% and more, not that many. Look like South Dakota, Minnesota, New York, Virginia, South Carolina, and Maine, right? Some of them. Some unavailable looks like this is the one unavailable, Idaho. So this gives us a little bit of good idea, like say how the state met the requirement and a pictorial view of that. So okay, so here is the statistic. 0 to 9 is 3 states, 10 to this 12, 18 is this, 9 states, and 40 to 49, 4, 50% plus is 2. Only 2 states did not have available data. So total is what, 48 states, right? So the total MSW recycling in million tons. So if I do that, and million tons would be this. So 85.1 looks like 34.4% was the last one in 2010. It's increasing. Look, the trend is increasing. That's great, right? So here are more data. So in this case, recycling rates of selected material in 2006 looks like 99% is auto batteries and other things. So it's 25 is the glass containers, and this is in 2000. So it looks like it's very close, right? 96 and 99. Some of them are increasing, some of them are decreasing. Ultimately, they are balanced, right? They are balanced. So here are more. This is the one I put data together that gives us all of them together from 1962 to 2005. Okay. So waste recycling and reuse, here is the one shows, this is the million tons, this is the percentage. Okay, so this is 55% and this is 45%, looks like. So 45%, we are able to do 45% of the recycling, reuse, combustion, and 55% landfill as of 2006. It's changing the last 10 years. I think didn't change that much, but could be a little change. So recycling and reuse again, advantage of recycling, public acceptance, resource conservation, disadvantage knowledge, economical and environmental impacts, cannot recycle everything. Here is some of the perspective. Recycling just 1 ton of aluminum cans rather than throwing them away can conserve more than 207 million BTUs, equivalent to 36 barrels of oil or 1655 gallons of gasoline. Every ton of mixed paper recycled can save energy equivalent to 165 gallons of gasoline. So you see how important they are, the recycling thing. So environmental impacts, organics and inorganics present in the solid waste sometimes escape if not managed properly and pollute soil and waters, surface and groundwater. But polluted soils and waters are health hazards to human beings and animals. So that's the environmental impact of solid waste. So recycling, again, tire recycling, advantage is the same, disadvantage is the same of the regular one that we said. Here are some of the waste recycling and reuse facility. Shows that some of the county, city might have something like that in there, right? So it's kind of free. You don't need to pay for it. So they have those things, different thing here. And here is the one of the facilities they are doing something. People even can bring recycled materials here, or they get it, they collect it from individual houses, bring it here and process it here. Here are more processing units for the recycling. This is kind of, I would say, they bring kind of like say waste together, then they probably separate those. It's a material recovery facility, MARP, or processing facility. This is also another recycling facility. Looks like they have those. They will be baling those, right? They will make some bales and other things. I mean, they will put it together so that it takes less spaces and it can be transferred to some other places or to some other manufacturers and other things. Here is the baling and putting it as the storing in there is taking less space compared to the raw ones. So ultimate disposal of solid waste. Those activities associated with the ultimate disposal of solid waste, including those waste collected and transported directly to landfill, semi-solid waste sludge from wastewater treatment plants, incinerator residue, compost or other substance from the various solid waste processing plants that are no longer further used. These activities are discussed in detail under the ultimate disposal of MSW in the landfill. So ultimate disposal would be MSW landfill is defined as a land disposal site employing an engineered method of disposing solid waste on land in a manner that minimizes environmental hazards by spreading the solid waste to the smallest practical volume, applying and compacting cover material at the end of each day. So this is I think regulated engineered design land part of it used as a landfill. There are 3 basic types of landfill: sanitary landfill, CTD landfill, and industrial landfill. the number of landfill appears to be decreasing with time as the recycling and recovery of the waste is increasing. So here is the number of landfill. It looks like number of landfill is going down because of some of them are getting bigger, some of them smaller ones getting closed, and some of them are expanding. So expanding means in the existing facility, but they don't count as a new landfill. So it's expansion of the landfill. So that's why the number is going down, but overall capacity may be increasing. So here is the one, I think the number of landfill in different state in the USA. It looks like Alaska has 322 and Hawaii has 8. Let's see, whichever your state is, since your Georgia has 76, Florida 95. Looks like Alaska has a more number, 322 compared to any other state. So it's a good observation, right? To see like how many landfill we have in different cases. This is in 2005 data, I think. So now it might change a little bit. I don't have the recent data. So this is shows a dump. The dump is not a landfill. This is a dumping site. Means people are dumping waste here and there. It doesn't have any control of groundwater monitoring, groundwater collection, leachate collection, gas recovery, gas collection, or gas monitoring and everything. No liner in the bottom and everything. But the landfill will have all of those. So when we'll do the landfill design in solid waste engineering, you guys will understand that better on that. So that's it for this topic. This is the end of the topic 7. So there are some homework from this topic. If you go to the topic 7 overview, you'll see the number of problems that you have to solve and submit as a homework. Okay. Thank you very much and good luck with this topic.